Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With the launch of their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, dedicated CPU and GPU instances, and worldwide data centers. Go to pythonpodcast.com/linode, that's Linode, today and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host, as usual, is Tobias Macey, and today I'm interviewing Tiago Peixoto about GraphTool, an efficient Python module for manipulation and statistical analysis of graphs. So, Tiago, can you start by introducing yourself?
Sure. So thank you very much, Tobias. So yes, I am an associate professor at the Central European University in Austria at the Department of Network and Data Science. I'm a physicist by training and practice, and I work in a field called network science.
And do you remember how you first got introduced to Python?
Yes, it was during my PhD. I was doing a lot of computation, so I do lots of scientific simulations, scientific computations, and this is something that, it has many aspects. So on the one hand, you want to run algorithms that are fast, but you also want to do things like plotting and high-level analysis. And then at that time, Python started permeating and percolating through the scientific community because it made things much easier. It's a very expressive language, easy to write, easy to understand, and it has it's very appealing for scientific computing as well. So this is what brought me into it.
And so, as part of the work that you've been doing for some of your physics research, that has led you to building the GraphTool library. So I'm wondering if you can just start by giving a bit of an overview of what it is that you've built there and some of the story behind why you felt it was necessary to create it and the overall goals that you have for the project.
So Python has this very appealing aspect to it. It's a very clean language. It's super nice to write. But it has a drawback, which is that it's a slow language. It's an interpreted language. And for scientific computation, that's a big deal because you want your code to run fast. You want to work with large data or do large simulations that you want to run as fast as possible. And if you just do this with Python, you have a problem. So I was working with networks. So GraphTool is a library to manipulate networks, to manipulate graph structures. I needed to work with graphs, and during my PhD, that was a topic of my research. So I needed to write code. I needed to write code to do this, and I wanted to do it in Python. But you can't just do it in Python. You have to somehow split it. So at that time, there were already other libraries. So I started this already in 2006, so it's quite a long time ago when I was in the middle of my PhD. And I think NetworkX, which is a library, it was a very popular library to work with graphs. It already existed at the time, but it did not attempt to solve the problem that I wanted, which is NetworkX is a pure graph library, a pure Python library. So it's implemented in Python, and there is no consideration at all to performance. So it didn't work for me at all. I couldn't use it to do my research. So I decided to take this NumPy philosophy, right? So NumPy is this very central library for numerical analysis in Python. And what they do is they just take the stuff that needs to run fast, the loops, the linear algebra stuff, and they just push it into C. They implement it in C, and then they apply essentially a binding to these data structures and algorithms that are implemented in C. So I wanted to do exactly the same thing, but for graphs. So GraphTool is precisely this. It's all the data structures, the main data structure, the graph itself, and the auxiliary stuff, and the algorithms, they're all implemented in C++, right? So not implemented in Python. Then you have some bindings to this, right? So whenever you run a function, GraphTool just dispatches to this underlying C++ layer, which then is very fast. But then you can do the high-level stuff in Python. So in the end, it becomes just programming in pure Python when you're using GraphTool. But then whenever the actual important bits or the important algorithms run, they run in pure C++. So you get the best of both worlds, right? You get code which is very, very fast, and you get to write the high-level code in Python. That's the idea.
And so in terms of the usage of GraphTool, as you mentioned, it's a library for being able to do analysis of networked data sets and graph analysis. But I'm wondering, what are some of the scenarios or industries or research avenues where somebody's likely to encounter some of these graph data sets or want to produce them?
Yeah, it's a very broad question. There are many, many scenarios where this can happen. I would say that whenever the data is relational, when it represents interactions between pairs of things, then you automatically have a network. So, for example, a friendship between people, even in a online social network, right? That's a dyadic relationship. It's a relationship between two people, two nodes in a network, who follows whom, for example, on Twitter. If you have this kind of data, then you automatically have a graph structure, right? Where you have nodes, right, which are the entities, and the edges or the links, which are the connections between them. Right now, for example, we are in the middle of, hopefully, past the middle of this global pandemic, and that's a process. If one understand how this process goes about, it's you have to understand a dynamical process that takes place on a network. Right, you have people which can be infected with the disease, they spread them to their friends. So these spreads over edges of the network. Many other situations. For example, suppose you have a website, you're Amazon, you're selling items, you want to understand what users are buying. So you can represent this as a graph where the items are nodes and the users, the client, your customers are also nodes, and then you have connections between them. These are the purchases. And then you can try to do all sorts of things. You might want to predict what kind of user will buy what kind of product. This is a recommendation system, recommendation problem. It's inherently a network problem.
As far as the actual representation of these networked data sets, I'm wondering what the format typically is that you've been working with and some of the formats that you support within GraphTool.
The data structure itself, mathematically, these graphs are just matrices. But in reality, there's an underlying property of all these networks that we usually work with, which is that they are sparse. So if you consider all these examples I've given you, like friendship between people, items and purchases, etc., most possible connections do not exist. Right? We say that these data sets are sparse, so these networks are sparse. So the actual existing edges are a very small subset of all possibilities. And this requires certain kinds of data structures. In particular, there is one which most of these algorithms are based on, which is a genesis list. So for each item, for each node, you just list its neighborhood, right? The edges that are incident on this node. It's a relatively simple data structure. In terms of format, there are many ways to store this in a file. The most trivial is just a list of edges, right? To just give a pair of edges. They tend to have very, very simple representations. Of course, it can get a little more complicated when you start putting attributes on the nodes, attributes on the edges. And there are a few standardized formats that, talking now about file formats, not necessarily memory formats, these are just standard. But for file formats, there are some variations, some standards like GraphML or GML actually, and GraphXML, etc. So these are the standard formats which GraphTool supports. It even has its own binary format, which is meant to be able to store and load with efficiency from disk.
Another way that I've seen a lot of people interacting with graph networks and graph data structures is with an actual graph-oriented database, such as things like Neo4j or dgraph, and there are a number of others that have built-in support for that. I'm curious what your experience has been of the overlap, particularly in the sciences, of people who are dealing with these networked data structures and people who are actually using a graph database to assist with that, and some of the ways that GraphTool might either complement or sort of obviate the need for a graph database.
So I think these communities are largely disjoint to a large extent. The reason I think is that graph databases are meant for applications where you're interested or you're allowed, or you can only look at a very small portion of the graph at any given moment. So you have a truly large graph that probably doesn't even fit in memory. And you're just querying this graph, looking at particular pieces of it, or streaming through its contents. These graph databases are used as infrastructure for websites and all sorts of things. Libraries like GraphTool and others like NetworkX, iGraph, and so on, they are used mostly by researchers. So these are situations where you can actually load the graph. They can be large, but they usually fit in a memory. Your laptop or your server or your HPC cluster, you can actually load the graph and then do some analysis on it. You run about the complicated algorithms on the whole network. That's typically how these things are done. So of course there are overlaps. I'm sure there are people that are loading graphs that are parts of a graph that exist in a big database and loaded them up in GraphTool to do some sort of analysis. I'm sure there are people doing this kind of stuff out there, but you don't see many people in research and academia using directly these databases because they're usually meant for storage and representation rather than the analysis itself. So I would say this is probably the point of contact that they have.
And as far as the kinds of analysis that you're going to be doing on these graphs, I'm wondering what are some of the typical operations or typical background that somebody needs to be able to effectively use a tool like GraphTool or some of the other network-oriented libraries?
It depends a lot. It varies tremendously, right, on what you can do, all sorts of things with it, and depending on what you do, it requires different kind of background. So if a researcher, you want to simulate some process on a network, you can use GraphTool to do that. You might want to simulate epidemic spreading or opinion spreading on the structure of the network, and you might want to investigate what kind of network properties, network structures influence this or that kind. For that, you need to, of course, to have a certain understanding of what it is that you're doing, and the GraphTool allows you to implement these things. Just give an example of predicting edges, like a recommendation system, right? You want to predict what the user is going to do if they have done this in the past, right? In terms of purchases on a website, you can use GraphTool to do this. You might be a researcher in a drug company and you want to predict whether or not if a person takes 2 drugs, if this is going to have an adverse reaction or a neutral reaction or a positive reaction. This is again a type of edge prediction. You can do that using the algorithms that are present in GraphTool. You might want to find clusters of nodes that are similar, right? So let's say in a social network, you have people talking to people, being friends. You might want to say, okay, are there groups of people here who are similar? This is a task known as network clustering. So this you can do with GraphTool. You might want to find what's the most important nodes in a network. So, if you want to vaccinate people, right? This is, again, a very timely topic. Suppose you have a finite number of vaccines. Who should you vaccinate first? Right. This is the kind of stuff you can do using the kind of questions you can ask and answer with network methods. Depends. So in terms of what background you have, depends on the question you want. So if you just want to do something simple, like load the network and like do a simple visualization, you don't need much in terms of background. But if you want to go deeper into these examples I gave you, yes, you need to understand a bit what's going on. And GraphTool in particular, there's quite a bit of documentation available in the website, in the doc strings, and I make the effort of putting citations there and citing to the source material. So it's actually a good place to learn things. If you want to know more about what particular function is doing, you can just go and read up the literature. So I did this mostly for myself as well because I forget things with everything, the documentation. In the end, it ends up also serving as a good reference.
Yeah, it's definitely an interesting use case for the documentation in the library of being able to point to further research to give a deeper understanding. That's something that I'll have to take a deeper look at once we're done with this conversation, because I think sort of graph structures and networked data sets are an interesting area and something that I've always been kind of poking at. So it's great that you're adding that extra information and those extra points for people to be able to dig deeper.
This is also coupled with my own research. So I should say that my main activity is research. I'm a researcher. I develop new methodologies and I ask scientific questions based on network data, try to answer theoretical questions as well. And what ends up happening is that I develop a new model or a new method, and this goes into the library, right? This library exists mostly for myself. I'm the primary user. Of course, I'm happy to make it available for everyone and make an effort there as well, but it reflects my research activities as well. So you usually see new code and new methods coming up all the time.
That's definitely an interesting sort of a living research paper in code.
That's exactly right.
That's awesome. And in terms of the overall space of libraries in Python for being able to deal with these networked data sets, you mentioned a few. NetworkX is sort of the canonical one that most people have come across. There's GraphTool that you're building. There's another one that I've come across recently called NetworkIt, and I'm sure that there are others that I'm not familiar with. I'm wondering if you can just give your sort of perspective on the ecosystem of tools that exist for these types of operations and your thoughts on GraphTool's position within that space.
Yeah, so the central point here is that GraphTool is meant to be fast. That's the thing that is absolutely a central goal here, right? So as I mentioned in the beginning, when I started doing this, NetworkX already existed. It was not a very well developed, at the time, it was as well developed as it is now. I think it was something like 1 year old or something. And I did notice it, But as I said, it's just central design of being implemented on pure Python. For me, it works more as a reference. You can look, how they do things, but cannot really employ it on large data sets, on large networks, or even to do repeated analysis on small networks. It's just too slow. So I'd say NetworkX, it's very easy for people to get started, and it's very comprehensive. There are lots of things there. But if you want to apply this, for heavy-duty computation, it very quickly becomes too slow. Other than this, I think there's iGraph, which is some library that I think has started more or less at the same time that GraphTool started. I was not aware of it when implementing this. It has a similar idea to GraphTool. It's implemented in C, and then it has some bindings. At the time where it started, I think it only had bindings to R, and then only later on they put in Python. And it feels to me that Python is not like a very core. It feels to me, although I have to be honest, I don't follow it too closely. It feels to me like it's not Python is not the central. It's just one of the appendages of iGraph. And there are more. NetworkKit, I think you mentioned, I think it has a very central design, which is very similar to GraphTool. I would say that the only difference there, it has competitive speed. It's not slower than GraphTool, but vice versa. I mean, they're basically this compatible speed-wise, but NetworkKit's a much younger project, and it has it's not as comprehensive as GraphTool. To be honest, I was a bit puzzled when it came out. I was like, okay, they're doing it again. Okay, good. But, I don't blame them for doing their own code. It's fun. So, but I don't have a lot of experience with it. Just took a look at it, and yeah. So this is more or less the landscape as far as I'm aware. GraphTool has this main advantage that it's a very fast, and there's more other things too compared to all these other ones. For example, GraphTool has visualization. I put a lot of effort on doing good visualization code. And this is something that NetworkX, for example, lacks. NetworkX, I think it has a visualization engine that's based on Matplotlib, which is a rational choice, but the visualization that it produces are not that nice looking. Well, of course, there's some amount of opinion here, right? But I think it's fair to say that GraphTool has more elaborate visualization teams, and it produces more interesting looking visualizations for larger networks and so on. This is true also compared to Graph and the others. So I think that's a good advantage of GraphTool. On top of this, it has, as I said, it connects to my own research, and I happen to work on, among other things, network clustering using statistical inference, which is by now the state of the art of this kind of thing, right? This is already available in GraphTool. It has very efficient code for this, and this is not available in any of these other libraries.
And as far as the actual implementation of GraphTool, you mentioned that the core of it is in C and C++ for speed with the Python wrappers for it. But I'm wondering if you can just describe a bit of the architectural aspects of it and some of the design choices and your overall design philosophy that has guided your development of the project.
The idea is to do heavy-duty stuff in C++. So actually, GraphTool is a relatively thin wrapper around a C++ core. So I use C++ with templates, right, which allows you to write code with quite a bit of abstractions, all of which completely evaporate during compilation, right? So you get to be able to write less, but end up with very efficient code. Although you have to, as a trade-off, accept a rather excruciating syntax, right? There's no comparison with Python in that regard. But if you pay this price, you get this excellent payoff, which is just very, very fast code. And yes, compact code as well to some extent. I use the Boost Graph library, which is this excellent meta library, right, template library for working with graphs. And I do reflect, so the Boost Graph library itself contains many graph algorithms. I certainly make use of this. So I base myself a lot on BGL, on the Boost Graph library. The idea is that, whenever you run a function in GraphTool, it automatically dispatches C++ as soon as possible. So, and by the moment it's running, Python doesn't exist, right? That's a central design choice here. The moment your CPU is hitting 100%, Python interpreter is out of the picture, right? You can get parallelization very easily as well, right? So I use a lot of OpenMP, which means it's very easy to use it at C++ level. So, for algorithms that allow this, that are parallelizable, you can make use of all your cores, which, by the way, is something that stands out in GraphTool as well. For example, with iGraph, it doesn't do that. It doesn't have many parallel algorithms. This is the general philosophy. It's not revolutionary. It's the same idea for that NumPy had, right? That's exactly how they do things. They don't use C++, they use C, but that's basically the same philosophy.
And as far as the overall goals of the project and some of the design and architectural elements, I'm wondering how those have changed or evolved since you first began working on it.
Yeah, it evolved as I did, right? Because the main target user is myself. The reason why I started doing this, I had no hopes of this becoming a long-term project. I just did it because when I write things, I tend to forget. So I decided to. I noticed right away in my research that there were certain things that I would like to use again, right? So I decided to. In fact, when GraphTool started, it was not even a library; it was a command line tool. That's why the name comes from. But quickly realized that it needed to be a library. So I started separating the stuff that I was intended to use in the future. Were just like ad hoc for a particular project. For the things that I wanted to keep around, I started documenting them very quickly because I tend to forget what a function does, what a parameter is, and so on. So my guideline is essentially what works for me, what I find to be clean, what I find to be choice. I'll give you some examples. There's lots of taste involved here, but I don't have a lot of experience with programming we use in NetworkX, because I use essentially GraphTool for everything. But if I compare NetworkX, they have essentially, for each variation of a given algorithm, they have a different function that does that variation. Where in GraphTool, I tend to put one function that does essentially a task, and then there are parameters that dictate how variations are done. I find this to be cleaner and easier to keep in mind also to write the code and to use the code. I find this kind of design choice better, but I don't have a principle behind it. It just feels better like this. And how has it evolved? Well, it became cleaner over time. I think there was quite a bit of unification. This is in the beginning, right? It's because I was essentially learning how to do all this, and I was correcting mistakes. Over time, this has happening less and less, and things are more or less converged into a coherent style, as far as I can tell.
In terms of the actual workflow of using GraphTool and building on top of it and analyzing graphs, you mentioned that it started off as a command line tool and then morphed into a library. So I'm wondering if you can just give a bit of an overview of how much of the command line nature is still available and how much of it is driven by other Python code that you're going to write and wrap around it.
This is gone completely. These are primordial times. It's just a library. And because of this workflow can vary quite a bit, right? Depends a lot of what you're doing. So it adapts to a very big variety of workflows. But I'll give you some examples. So what I find myself doing very often is using an interactive session. So just open an interactive Python shell. I don't use notebooks very much, but you can definitely use this in a Python notebook. And it has built-in support for this. Like all the visualization, for example, works perfectly fine in a Python notebook. And then you load a file or load some other data and convert it into a graph format. You run some algorithms, do some visualization in an interactive way. So this is a very typical usage. Another thing that I do very often, and I imagine other people do too, is run GraphTool in a HPC, right, in a cluster to do some heavy-duty analysis, thousands, millions of graphs, or graphs with huge size and things that might take days to run, etc. This is the other usage pattern as well. So of course, as a library, it's totally suitable for this as well. And you're not helping to destroy the planet because you're actually using all these cores for actual computation, not just for the Python interpreter to be shuffling things around, right? So it's efficient for that. So it's meant to get the best of both worlds in this regard, right? So it feels like a Python library when you're using it, but it's also very efficient. Now, to be fair here, I think this, as I mentioned, it reflects a lot, the design choices of the library reflect how I think, what I think is intuitive, but also the constraints of the C++ data structures, right? So the graphs, for example, graphs, the nodes and the edges, they have representations which are less flexible than, for example, what you get with NetworkX. NetworkX, you have the graphs are just dictionaries of dictionaries, and they can be any objects. Here, of course, it doesn't make sense to develop a library like this because it needs to run fast. So the graph data structure is based on a genesis list. Then we have property maps that map these nodes and edges to anything you would like. This is, of course, general enough. You can do everything with it, but you have to think around these kinds of concepts. I'm, of course, perfectly used to this, but a person that comes from NetworkX might think at first that this is a bit constrained, but it's a requirement of the design choice.
As people start to get involved with using GraphTool and start to build analyses on top of it, how much understanding of the sort of graph theory and some of the associated algorithms do they need to be aware of to be able to be effective with it versus being able to use your documentation and references to just discover that and explore along the way?
Depends on what they're doing. So you can do something very simple. Just so if you're just cleaning up some data, you can use GraphTool for that. But then you don't have, of course, to go into it. If you're using some more complicated algorithm, if you're trying to find the maximum matching, let's say, of a graph, you have to know what that is in order for you to make sense of what the output is. So it depends on what you're doing. The documentation is very extensive, and there are many examples. So I hope at least people can use it to explore and to learn things. So it tries to explain in a concise way what everything is doing. It gives references. So even if you're not entirely familiar with the concepts right at the beginning, you should be able to get somewhere just by looking at the documentation.
In terms of the systems and applications that you have been building with GraphTool and that you've seen people build with GraphTool, or systems that you see that are using more flat data structures or nested documents that might benefit from a graph structure, I'm just wondering if you can give some examples of ways that using graph algorithms and graph structures can simplify types of analyses that you have seen people sort of struggle with in other formats.
I think graph analysis allows you to see the big picture of the data. If you don't represent it like this, then you are often constrained to do simple aggregate statistics, right? But if you represent it as a graph, you can actually see the relationship. So for example, I'll just go back to an example I already gave because it's actually a good one. So recommendation systems, right? You have users doing things, user buying things, your website, so customers and items. If you construct it as a graph, then you can do things that you couldn't do before, right? If you don't construct it as a graph, you can just count things. You can count, okay, how often has this item been bought or things like this, which is very basic level of, from this you can extract only a very basic level of understanding what's going on. But once you start looking at these relationships, then things change quite a bit. Then you can, for example, do clustering. You can see, okay, what are the categories of items that you have? What are the categories of customers that you have? And what are their behavior? You can start to be able to predict what they're going to do. These are all things you couldn't do if you don't represent it as a graph. Now, if this simplifies, I'm not sure. It certainly exposes a lot of the structure. Yeah, so I'm not sure if there is a situation where the graph simplifies, but it allows you to do all sorts of things you couldn't do before.
And so GraphTool, as you mentioned, is a project that you've been working on for a number of years, and you've been adding new capabilities and new algorithms to it for a while. And so for somebody who is more of a newcomer to GraphTool and is just adopting it, maybe using it somewhat naively, I'm curious if there are any aspects of the library that you think are often overlooked or underutilized, or that you think deserve to be called out specifically that might help people who are newer to the project.
Yeah, there are a couple of things I think that are hard to explain in the documentation, right? Because once people I think when they heard of the library, they go to the website and they read the documentation. There are a couple of things that are hard to express in the documentation, but I think maybe people don't notice. For example, GraphTool has interactive visualizations. You can, in an interactive session, you can load up a graph, you can draw the graph in a window, and you can actually use your mouse to move the nodes around, to rotate the graph and do other basic manipulations. We were talking before about other libraries, and I mentioned the libraries that I know, but there are also other kinds of programs for the network analysis that are visual. They're not libraries. They're things like Cytoscape and Gephi, for example. Gephi, for example, is written in Java, and it's a window. It's a graphical program with a graphical user interface where you just load a network and you visualize the network. And so it's a completely different paradigm, right, than a Python library. But the GraphTool, you can actually do quite a bit of interactive visualization, right? You're actually using your mouse to do things and to do adjustments and zoom in, zoom out, and this kind of thing. And this is very hard. You cannot put this in a doc string. You can write it, and if they read it, they'll go, aha. But it's the website. There are some examples, but it's hard to tell people this. But it's definitely there. Another thing, this is actually documented, but I'm not sure to what extent people are really aware of it or use it, which is that you can use GraphTool together with C++, so you can write C++ extensions. So what happens, there's a problem with this paradigm of writing a Python library which is dispatched to C++, which is that whenever you think of an algorithm which is not implemented in a library, of course, There is a low-level Python API to manipulate the graph tool, like adding the edges or navigating through the nodes and edges. Of course, you can do that via Python. But if you implement an algorithm using this low-level API, it's going to be just as slow as if you implement, as Network X or anything else, because you're not really doing anything in C++. But what you can do is write extensions, C++ extensions that just run as fast as the native code in GraphTool. This is documented, and there are some examples in the documentation about how to do this, but I think this is underutilized. I think people could make use of this. I think it's probably because, less people are familiar and inclined to write C++ code with templates. But if you are so inclined, you can definitely do this, and this gives you quite a bit of an advantage.
Conversely to my question about places where people should be using graphs and aren't, what are some of the cases where you've run into the situation of you have a hammer and everything looks like a nail, and you've tried to do something with GraphTool that was actually much simpler if you don't try to think about it as a graph structure?
Absolutely. This can happen too, yes. Although, of course, I'm biased. But yes, this does happen. If you give an example, like there are some domains of applications for which there are specialized tools that work better. For example, image processing. Right. I mean, there is no need, I think, most cases to think of use networks or graphs algorithms. The guiding principle here, I mean, graphs are relatively general mathematical structures. So if you want to, you can see, graphs everywhere. But there is a particular property here that's important for these libraries such as GraphTool to make sense, which is the property of sparsity. Right, so the networks that we use, they tend to be sparse. I think I explained already this before, that most edges in the network don't exist, right? So in other words, every node has only a finite number of neighbors, right? If you start thinking of images and other kinds of structure which are actually dense, if you start thinking of them as graphs, you can do it. And in fact, people have done this. You can find papers and people doing this kind of, converting image analysis into a graph problem. But I think it doesn't really help. I think it adds unnecessary complexity, as I mentioned. There are more specialized tools that are better in these cases.
In terms of projects that you've built with GraphTool or things that you've seen other people use it for, what are some of the most interesting or innovative or unexpected ways that you've seen it used?
I find it being used in research all of the time, and this gives me a tremendous joy. It's very cool when you open up a paper and there's like a graph, like, I know this has been done with GraphTool, we can tell, right? And this is cool because even if it's a menial task, even if they're just doing like a graph visualization, which is a rather basic functionality of GraphTool, I feel very happy because I feel like I have helped a little bit this research to do something. There are all sorts of things. People are using the methods to do analysis of a gene sequence data, for example. It's all over the place. Tissues in cells. This last example I saw, there was a paper, I think, in Science some years ago where they had the placement of cells in tissues, and they had like a lattice representation of this. They used GraphTool to analyze this. I was totally blown away. I never thought they would be able to. I never imagined this as a type of application.
You mentioned a few times citations that you have within GraphTool, and I know that there's also a growing trend of having citations for open source software libraries in research, and then there's also the archetypal challenge of working in academia of publish or perish. And I'm wondering what your experience has been as to the overall weight that your open source software contributions have in your role as somebody working in academia versus the pressure to, have published research papers and, just the overall balance that you have in terms of the effort that goes into the different avenues.
Yeah, that's a very interesting question. The reason why I do GraphTool is not to cater to my citations, because I wouldn't have been smart. I use it because I get pleasure out of it. It does help my own research because it organizes what I have. It helps me organize my tools, and over time you build this little compendium of things. But I do it because it's like a Zen garden for me. I have two modes of operation. So when I'm working on a research project, I'm thinking of a new concept or a hard problem, and it's very intensive, and you're thinking a lot and trying to come up with something. But then when you're doing things, of course, when you're writing codes like this, can be like this as well. But also there's quite a bit of it, which is, taking care of the documentation or the doc strings, building the package, the website. All these things, for me, it's a different mode of operation. Right? It's like, as I mentioned, a little garden that you're setting up, and this can be relaxing. I tell this to people, they think it's weird, but I don't think so. I do it because gives me pleasure. It's a thing that I like to do. I do think it helps other people too, right? It's not the most used graph library, but I'm sure I know for a fact that other people are using it, and this is great. And this matters. I think it's important for research to have this kind of activity, even if it doesn't count directly to your citation counts, right? At some point, if you only think about this, you're going to go crazy.
And in terms of your experience of building GraphTool and using it for your own research, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
The biggest complaint people make about GraphTool is that some people find it difficult to install. So I've heard this very time. So of course I try to address this and work with. The problem here, of course, is that the library is a bit deceptive. Python users, they expect a library is a text file that you download, right? And then it just runs because it's an interpreted language. GraphTool is not this. GraphTool is a wolf in sheep's clothing, right? Python has an API, but it's a C++ library. It has C++ dependencies. You need to install Boost. You need to have a compiler, right, if you want to compile the library. And then, as I said, I developed this in 2006 when it began. Over time, of course, Macintosh, macOS has become kind of a de facto standard in science, although that's not what I use. This kind of operating system doesn't have any built-in package management. So can you imagine somebody who doesn't have a package management having to install by hand, Boost and GCC and all this stuff? It's a nightmare. Of course, on GNU Linux, it's not an issue, right? Maybe you have to wait a little bit for the thing to compile, but it's not a big deal. But I noticed that over time, to a different generation, younger generation of people coming, they're not used to the figure making install. This is something that's for older people, right? So, of course, this is not what you need to do GraphTool. It's very easy to install GraphTool. Nowadays, you can use it's packaged in Anaconda, packaged on Homebrew for macOS. If you use Debian, Ubuntu, there are packages for it. There are packages for Arc. I did make a lot of effort to try as much as possible to do this, but you're going to find corner cases that for whatever reason they cannot use one of these packages and they have to do it by hand, and they get surprised by the fact that it takes a long time to compile because of the template programming, which the compiler is not that optimized to handle this, so they take a long time and long memory to compile, etc. So this, I think, is something that required some effort to improve, and the state is better now, but can still be improved. So I think this is maybe the Achilles heel of this kind of project.
For people who are looking for a library to be able to do analyses on graphs or construct graphs and do some manipulation on them, what are the cases where a GraphTool is the wrong choice and they might be better served with a Network X or a Network Kit?
GraphTool does not include every possible algorithm. So you might need something that's not implemented there, just I didn't have the time to go through. GraphTool is essentially a one-man's project, doing basically everything. Once in a while, some people help. There are some people have helped with this or that, with some things over the years, but I'm essentially the one doing everything. It's fairly extensive, it's particularly because I was able to I implemented quite a bunch of things myself, but I have been able to use what the Boost Graph library had in place, which was quite a bit of thing. I had quite a range of algorithms, but maybe did not find something. I think Network X has actually a larger coverage. It actually has different algorithms that, because of my profile, I haven't needed to implement these algorithms. They tend to be biased towards the kind of things that I do. So it might be that somebody doesn't, searches for a given code that's not there, and so they have to use something else. So this is definitely a possibility. Another one has to do with what I just said. It might be that they don't have a binary package for their particular combination operating system. I've encountered many people have a very old laptop with a ridiculously old version of macOS that is not compatible. They have a hard time installing. For some corner cases like this, it might be burdensome to get going, right?
As you continue to use GraphTool for your own work and develop it and maintain it, what are some of the things that you have planned for the near to medium term of the project?
I'm not planning a big revolution with it. I will just continue to expand it and put more things, maintain it, clean it up. It's connected to my research, so I do have a research agenda related to network inference and reconstruction, which is going to become part of this package for sure. There are some things I would like to do, but this depends a little bit on external tooling. I'm very interested, for example, of exploiting GPUs, right? So offloading some of these codes to GPUs. Some of them, I think, could benefit from this. It's not very difficult to do using things like CUDA and so on, but It's right now at the moment a bit cumbersome because of the packages available for these other things on different systems. But this is something I'm looking towards implementing, which I think would be quite cool. I'm also paying attention to the development of C++. So C++ is a very live language, right? It's been evolving quite a bit with these new releases every couple of years occur. They tend to help a lot libraries such as GraphTool, which depend a lot on metaprogramming. This part of C++ is actually evolving quite a bit, and I'm looking forward for improvements that make compilation easier and makes development easier too.
Are there any other aspects of the work that you're doing on GraphTool or the ways that you're using it in your research or the overall space of graph algorithms and networked data sets that we didn't discuss yet that you'd like to cover before we close out the show?
No, I think you covered quite a lot. I would recommend people just take a look at it if they find it interesting, right? It's free software. You can just get it and play with it. That's surely the best way to learn about it.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing or contribute to GraphTool, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. This week, I'm going to choose a bit of a self-serving pick to announce that the book that I've been working with O'Reilly on for a while now of 97 Things Every Data Engineer Should Know, so just a collection of different essays from people in the field, is finally published and released. So I'm happy to see that out the door. Definitely want to let people know that it's there. So I'll add some links in the show notes to where you can find it. Thank you very much for taking the time today to join me and share the work that you've been doing with GraphTool. It's definitely a very interesting library, and I'm excited to learn that you have all of these different citations and references to relevant material as you explore the overall space of graph algorithms. So I'll have to take a look at that. So thank you again for all the time and effort you've put into the project, and I hope you enjoy the rest of your day.
Thank you very much, Tobias, for the interest.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.